Today we're going to talk about physical and chemical properties and physical and chemical changes. This is podcast 1.3. So along with intensive and extensive properties, there's also physical properties and chemical properties. Physical properties are properties you can observe without changing the identity of the substance. There are things that you can measure or observe without changing what the substance is. So for example, you can measure the mass of a substance, say of salt, and by taking the mass, it's not affecting what the substance is. Volume, temperature, you can describe the texture of the substance. Those are all physical properties about that substance. You can observe them and they don't change the identity of the substance. A chemical property does change the identity of the substance. So for example, if I know it reacts with water, that is a chemical property. Maybe it doesn't react with the oxygen in the air. That's another chemical property. If it rusts, if I set it outside, that is a chemical property because all of these things would affect the identity of the substance. That can be tricky because you think it doesn't react with oxygen. That doesn't change what it is because it doesn't react. The fact that we're talking about that it doesn't react, that react word is what makes it a chemical property. Inert. Inert means it's not reactive. The noble gases on the periodic table are all inert. They don't react with other elements or other compounds. So inert is a chemical property because we're talking about something not being reactive. And then we have chemical and physical changes. So a physical change, just like a physical property, is a change that occurs that will not change the substance. So a physical property was something you observed without changing the identity of the substance. A physical change is something that happens that really just changes the look of the substance. It doesn't change what it is. So examples, maybe you have a piece of wire. By bending the wire, you're changing the shape of it. So that's a physical change because you're not changing what that wire is. If it were copper wire, by bending it, copper wire is still copper wire no matter the shape that it's in. Grinding it up, crumpling a piece of paper, the paper is still paper, you haven't changed what it is. Splitting, crushing, all the phase changes, we'll talk about those in a second, but that's like melting, freezing. That doesn't change your substance, it just changes what it looks like. Dissolving can be confusing. If you think of somebody who maybe has coffee and you put sugar in your coffee, well, the sugar almost disappears. You would think maybe it just went through a chemical change that it's not there. It really just dissolved into really, really tiny parts that you can't see anymore. So dissolving is just a physical change. It didn't change what the substance was. The sugar is still sugar in your coffee even though you can't see it. And then crystallizing is the opposite of dissolving. Have you ever set out salt water, or maybe you haven't, but if you set salt water out, a little bit of it, eventually all the water evaporates and you're left with salt crystals. That's the crystallizing. The salt was in there, it was dissolved, but as the water evaporated, we're left with just the salt. So crystallizing, when you get all those really pretty crystals, is just an example of a physical change. Here are the phase changes. So this is, again, these are all physical changes still. If we think of water, that's usually the easiest. We can have solid water, which is the ice, liquid water, and then we can have water vapor, which they're representing as clouds in this. All these different phase changes that any substance can go through, but water is the easiest to envision. These are all physical changes. You're changing the appearance, but not the identity of the substance. So I would pause here and I would copy this down so that you know all these 6 names. I would also copy these right here where it says heat energy is released and heat energy is taken. So take a second, copy this down. All right, so those were all physical changes. You changed the appearance but not the identity. This is chemical change. A chemical change is just another way of saying a chemical reaction. And in chemical reactions, you get new substances. You take something and you turn it into something else. So our example from our last podcast was that we had water. And when we run an electrical current through water, it's split up into hydrogen gas and oxygen gas. So because this is a process, this is a reaction, we're forming a new substance. We had water, but we end up with the hydrogen and the oxygen. So all those chemical reactions that we usually see, those are examples of chemical changes. You've changed what the substance is. Other examples are rusting and then fermentation. Well, what do you look for? How do you know that you just saw a chemical change or a chemical reaction? Because sometimes, for example, dissolving, people think that that was a chemical reaction. There are 4 indicators that you can look for. The first one is if you see bubbling. Bubbling tells you that a chemical change probably happened. You're forming a gas that wasn't there before, and the gas you see is the bubbles. So formation of a gas is one piece of evidence that you can look for to tell you that a chemical change happened. The second one is the formation of a solid that wasn't there before. There are chemical changes where if you take 2 liquids and dump them together, you're going to see a solid form that wasn't there before. And we'll do a couple of those in the lab that goes along with this podcast. But you can produce a solid that wasn't there from 2 liquids, and we call that solid a precipitate. If you see a change in color, so maybe I take 2 clear liquids, I dump them together, and all of a sudden I have a yellow liquid. That indicates to me that there's a new substance that wasn't there before because of the different color. The same thing goes for over here. In fall, when you see all the leaves change color, they're going through a chemical process, they're going through a chemical reaction, and that's what causes them to change colors. Also changes in temperature. If you see the temperature rise or lower, either way, you're seeing evidence for a chemical change or a chemical reaction. So those are the 4 things really important that you write down so you know that you're watching a chemical reaction. Here's the last thing. We talked about that change in temperature. Temperature is just a measure of the amount of energy in a system. So all chemical changes involve a change in energy. Energy can either be given off, and we call that an exothermic reaction, or it can be absorbed from the surroundings, and we call that an endothermic. So exothermic, the energy is exiting. Endothermic, the energy is going in. It's coming into the system. With an exothermic reaction, you're going to see the temperature is going to go up because your thermometer is going to read all that extra energy coming out as an increase in temperature. And in an endothermic reaction, you see the opposite. You see the temperature drop down. Energy is getting sucked out of the system. The temperature drops. And the last thing here is just a picture for you to visualize endothermic and exothermic. I don't think you need to copy them down, just watch for a second. This is an exothermic reaction, so potential energy of the system. You look here, you start with a reactant. So the reactant's right here, it has a set amount of energy. For the reaction to get going, it has to gain energy to a certain amount that lets it go. So reactants, they pull energy in. Maybe it's by you heating it, or it just has enough from the surroundings. It heats up and eventually it sets the reaction in motion. And at the very end, what we see is the products are at a lower state of potential energy than the reactants. So when the reactants had more energy, and then it ends up that it gives off all that energy to a product, and the products are in lower energy state than the reactants, that's an exothermic reaction. Energy was given off, it was lost, it was released. So this is where we said that the temperature would go up. All this released energy is what you see as temperature rising. Over here, we have the reactant starting at a certain amount of potential energy. You have your activation energy, which gets your reaction going. And at the end, when we look at the products are at a higher energy state. So this was an endothermic reaction. Energy was absorbed, and we would see a decrease in temperature. And that's because the temperature is dropping, energy is being taken into the system to do this chemical reaction. So when the reactants have more energy than the products, that's exothermic. When the reactants have less energy than the products, that's your endothermic reaction. And that's the end of podcast 1.3.